Hello students, today we will be starting with a new topic, that is biomolecules, and this module we are going to discuss about the introduction to biomolecules. So now the first question comes, what is our body made up of? Our body is made out of various cells which act as a basic unit of life. And this basic unit is made out of complex molecules. Which are those molecules? Then these complex molecules are nothing but biomolecules. And what are the biomolecules which we come across in day-to-day life, or rather which are the biomolecules found in human system? Let's see for this. The biomolecules which we are going to discuss are, the first one, carbohydrates, which are nothing but major source of energy. Next comes proteins, which are required for proper functioning of our body. Nextly, we are going to discuss about lipids, which acts as an insulator and source of energy. Next, we would be learning about enzymes and hormones which catalyze various biochemical processes. After this, we are going to study about vitamins which are essential for controlling the vital functions of our body. And lastly, we are going to learn about the nucleic acids which regulate the genetic characteristics of an individual. Now, before starting with the study of carbohydrates, we need to understand what is a basic definition for carbohydrates. The definition of biomolecules goes something like this. Biomolecules are lifeless molecules which combine in specific manner to produce life or control biological reactions. Now, we would be starting with our first biomolecule, that is carbohydrate, and as the word suggests, it can be broken down into two different terms. First, carbon, and next one is hydrates. Now, a question arises over here. What is the simplest ratio of H and O in water? It is 2:1. Suppose if we add carbon to this, then the simplest ratio of carbon, hydrogen and oxygen becomes 1:2, 2:1, and that is nothing but the simplest ratio of carbon, hydrogen and oxygen in carbohydrates. Now, let's start with the examples. The first example which you can likely take is glucose, having a molecular formula C6H12O6. Now, could we write this same molecular formula in something like this? Yes, it can be written down as C6H2O6 times. Let's see one more example. What if we have sucrose, which has a molecular formula of C12H22O11? Now, this sucrose molecule can also be written like this, which is C12H2O11 times. So, can we say that carbohydrates are nothing but represented by a general formula of CXH2OY times, where X can be equal to Y or it cannot be equal to Y? And now, moving further, we can also say this, that carbohydrates are nothing but compounds in which carbon gets surrounded by water molecules, and thus they are rightly referred as hydrates of carbon. So, let's take certain more examples. If we happen to have an example of acetic acid, that is CH3COOH, again, acetic acid can be represented as C2H2O2 times. If we take a molecule of formaldehyde, then the molecule can also be represented like C1H2O1 time. And lastly, if we happen to have a molecule called as rhamnose, its molecular formula becomes C6H12 O5. Now, acetic acid and formaldehyde, can they be represented with a general formula of carbohydrates? Yes. But are they carbohydrates? No. We all know acetic acid is a carboxylic acid and formaldehyde is an aldehyde. So, what we can say as of now, being an aldehyde, being a carboxylic acid, yet they are satisfying our definition. Similarly, if we talk about rhamnose now, this being a carbohydrate cannot be represented by CxH2OY times. Thus, we all can say that there is something wrong into our definition. Now, the correct definition for carbohydrates become: carbohydrates are optically active polyhydroxyaldehydes or polyhydroxy ketones, or the compounds that can hydrolyze to give polyhydroxyaldehyde or polyhydroxy ketones. We would be learning this definition very shortly into future modules. I hope as of now it's very clear. Till this time, thank you students.